Tessa. I'm from UCIT, Department of Research and Development. And my department, along with UC Libraries, these are our culminating 2018 Data and Computational Science Series events, so thank you for being here. We are very happy to have Dr. Sandra Gesing with us to present on Science Gateways. She's a research assistant professor in the Department of Computer Science and Engineering and a computational scientist at the Center for Research Computing at the University of Notre Dame. Prior to her position at Notre Dame, she was a research associate in the Data Intensive Research Group at the University of Edinburgh, United Kingdom, in the area of data intensive workflows, and in the Applied Bioinformatics Group at the University of Tübingen, Germany, in the area of science gateways and grid computing. Her research interests include science gateways, computational workflows, and distributed and parallel computing. She is heavily involved in the NSF-funded Science Gateways Community Institute, which she will talk with you all about. And she's the founder of the European Workshop Series International Workshop on Science Gateways, taking place for the 10th time this year. The significance of Science Gateways has also been recognized by the IEEE, and she chairs and coordinates the IEEE technical area on Science Gateways. The Data and Computational Science Series is supported by a Universal Provider Award from UC's Office of the Provost for Faculty Development, and we were recently awarded another round of funding, so keep your eye out for the 2019 series. Without further ado, thank you all for being here, and please welcome Dr. Sandra Gesing.
Thank you, Amy, for the nice introduction. So, yeah, I'm Sandra Gesing, as she already said. And I make the joke again that I lived for a while in Edinburgh, and you hear that my German accent. So I say, oh, everybody can be lucky that I didn't pick up on the Scottish accent additionally, so that I have only the German one. So yeah, I will talk about science gateways, but first of all, a short introduction where I'm from. So I'm now for 5 years at the University of Notre Dame. Most of you probably know where it is. It's in the middle of nowhere of northern Indiana. And we have 4 undergraduate colleges, 35 research institutes and centers, and about 12,000 students. And you can see here on the right-hand side the stadium, which is on campus, this touchdown Jesus over the goal. And normally at this time it looks already like this, but we don't have snow yet. So I'm a computational scientist at the Center for Research Computing, besides being research faculty for computer science and engineering department. So at the Center for Research Computing, I talk a little bit about what we are doing there. So we are really supporting software development. We are developing software and profiling software. In science gateway development, we are a big group for cyber infrastructure and science gateways. The computational scientist support, for example, is really creating the design for projects and writing on grants with other faculty together. It's really collaborative research with different faculties on campus then. We have also the HPC team with system administration and prototype architecture. So we are working, for example, on testing Docker containers with GPUs, really things like projects and prototype architectures. And we offer to the campus computational resources, more than 25,000 cores, and storage resources, more than 3 petabytes of data, and also access to XSEDE, to the national HPC infrastructure. So you know what XSEDE is, everyone? No? So XSEDE is a consortium, it's a project of different universities, and you can apply for an account and then really use, US-wide, different HPC resources. So if, for example, on campus are not enough resources that you can have a high-performance computing job running there, you can apply for this. And they are funded that you can run your compute-intensive jobs. And you can get access often via resources on campus that somebody can. So the XSEDE campus champion is here. So he can help you to get access to, maybe you should, so the XSEDE campus champion is here and can help you to get access to big resources if you need that. Yes.
My name is Brett Goodman. I work with Jane Combs in R&D. And as Sandra mentioned, I'm here to help facilitate the use of resources like XSEDE, also the Ohio Supercomputer Center, or resources that are here local to UC. So if you have any questions about how to use those resources or what's available, just let me know. I'd be happy to talk to you.
Oh, great, thank you. So yeah, at the Center for Research Computing at Notre Dame, we have about 50 researchers, research programmers, and HPC specialists. The picture here, the lower picture, shows our HPC center in the middle of the city. It's an old Union Station. It's a quite awesome building. So when we talk about research software, there was this nice survey about research software in the UK and in the US. And 90% answered in the UK that they use for their research software, and in the US it was even 95%. And they answered they cannot continue without software to continue their own research, with 63% in the US and 70% in the UK. So research software is a really big part of research and science nowadays. So if you look at technology-enhanced research, so there's really the increased complexity of the research question we can ask nowadays. We have sometimes research questions we couldn't have even asked 20 years ago because there wouldn't have been the means to find it out. And we have increased complexity of hardware and software, and also the skills required for it, and also a greater need for openness and reproducibility. So you might have heard about that in the last 4 years, often people talk about the reproducibility crisis, that experiments cannot reproduce, that results are in papers, but yeah, collaborators, partners, or even people who just want to see how it was created, the result, cannot reproduce the result. So there's an opportunity to integrate research with teaching and have a better workforce preparation. And that needs really that we need end-to-end solutions that provide broad access to advanced resources and allow everyone to tackle today's challenging science questions. And these are science gateways. That is our definition of science gateways, really these end-to-end solutions. And if you look at the scientists, researchers, or in humanities, researchers, they're normally not, or generally not IT specialists. So they have maybe data and compute-intensive problems, and there are all these new, novel web-based agile frameworks out there, and access to distributed data and computing infrastructures like XSEDE or on campus. And you have also high-speed networks. So, but I can tell you from my own experience having a collaboration with India, to get data from India to the US is still a lot of effort and still not easy, despite all the technical possibilities. So on the other hand, there are also tools and workflow engines to support the researcher. You see all these nitty-gritty details of technical solutions, and normally this is not what a researcher is concerned about. So there's a need for science gateways to help them to make the little bit sad Einstein to a happy Einstein. And so when we talk about science gateways, we are not bound by the expression. So you might have heard about a virtual research environment. In Europe, often they call it a virtual research environment. Or maybe you have heard a research portal. Or it's a virtual lab. Virtual lab is mostly used in Australia as an expression. Or it's a collaboratory, or it's a cyber infrastructure. So we are not clinging to the expression of a science gateway. It's a concept about usability to have an end-to-end solution, whatever kind of technique data you want to support. So, and if you look, for example, at this, so gateway users are 77% are really active XSEDE users. For example, XSEDE is this, as I said, this national infrastructure where you can get resources, HUBzero resources. And already at end of 2013, the users who are using it via command line are less than the ones who are using it via gateways. And at the end of 2016, because of 2 science gateways, it really picked up. That a lot of users were, so much more users were accessing XSEDE via gateways and via command line. And one of these gateways is Cypress. It's a phylogeny gateway. I will show the example. And ITASA is in proteomics. So Cypress, this is the example for the Cypress Science Gateway. And you can see here, it's a simple interface, but that makes it so easy to use for the people, because they search for a certain tool, they know what they want to use, like whether it's RuxML or Mr. Bias or Beast. They can select directly the tool in a web user interface, and the XSEDE connection is beyond it. They don't have to do anything on the command line, they can start everything here. And you can see the usage statistics, which is quite up to date until September, and really new users are picking up each year still. The total users are increasing. Also the repeating users are still really increasing to a high level. So this is the graphics on the right side. But also the use of CPU hours. And if you look at that, it's 104 billion core hours of XSEDE time distributed to scientists. That is a very impressive number. And it is supported by 4,500 publications. So that makes it also for academia then interesting for researchers to be involved here. So another science gateway is Cypress. It's also in the life sciences, and this is an example where you can, have data, for example, from next-gen sequencing data, where people can collaborate. So it was created on basis of Apache Agave, the Agave API, sorry, not Apache Agave, Agave API. So this is one of the examples where active users also are picking up. There are over 30,000 active users, over 3,000 institutions are using the solution. Another nice example, only to show also different ways, is Vectorbase started as a data platform like 10 years ago. It's created and it's hosted at Notre Dame, and with a lot of collaborators who uploaded also their data on vector-borne diseases and next-gen sequencing data. And then people started, oh, it's so fantastic to have all this data in one platform. Now we would like to use tools with it. So in the last 6-7 years, more and more tools were added to the platform that people can select the data and directly do further analysis in the platform. So anyone from astronomy here? So this is one example for astronomy. There's different, these are even different tools and different science gateway itself. But you can see there's a nice description. People can select what they would like to have a look at. It's a different look at field than the other ones I've shown to you, but this is also science gateway, but for astronomy. Further example would be in climate research. So SPACES is also researches on climatic effects on species. Even I know our political climate doesn't look at this research too much at the moment. Yeah, there's science gateways for it. Or something like the CyberGIS is geospatial data in a gateway, or with a HydroShare portal connect data between different portals. This is only one of the examples, so we can go into more examples if you're interested. But the humanities, sorry. Yeah, of course. Humanities Commons is one of the examples for humanities where there's a data collection where really people can exchange text mining tools and different, build up a network around text mining and data mining. So now I should. So these were all examples. So if you are interested in more examples for a different area, just come back to me. I can find more examples for your research field, or that we can have a look together on it. Any questions up to here? So in 2014 we did a Science Gateways survey, and this was sent out to 29,000 persons because we wanted to find out what does the community really need as services if we would have an institute. A Science Gateways institute that has developers, but that helps also the users to use Science Gateway. So to keep Science Gateways also sustainable. And we got 5,000 responses from across the domains, and 52% from life, physical or mathematical sciences, and 32% from computer and information sciences or engineering. And often people talk about Science Gateways as more about starting tools. No, it's really also about data collection. It's really sharing data, have open access to data, or share in a group data with each other. So 45% of the people we sent it to said that they develop data collection, and 44% develop data analysis tools. So you can see it's really tools, data, workflows. Science Gateways have a broad range of services. So, and people answered like what services would be helpful, and this is sorted in which regard they would be interested mostly in. And 72% said that they want to know, evaluate their tools, their gateway. They want to have an impact analysis, a website analytics, to see how many people are using which functions I have in my gateway, on my website, in my research software. And what was really thrilling for us was that 67% said they want to adapt technologies and not reinvent the wheel from scratch again, because there are so many mature solutions now out there that it's good to reuse them instead of bringing the next technology on the market. And also the web visual graphic design shows that there's a lot of interest in making it nice for the user community, and not like that it's not like a difficult command line tool where people really have a struggle to start it. So you can go through the list. There's choosing technologies which is near to adapting technology, or usability services which is really focused on helping users. And visualization is a big topic, because one picture says more than 1,000 words, as we all know. So visualization is often really helpful in research, or necessary. So you can see there's a certain trend how we build on the services. And the other question, one of the other questions we asked was what people think what they need to create a science gateway. And so we asked whether they had a certain expert already, whether they wish they had it, or they think they don't need them. And the two values you see here is, the blue one is wished we had this, and the green is yes, we had it. And the one which is missing is no, we don't need that. And if you look at it, it's quite interesting, for example, that people think that they don't need a security expert, or only 40% think that. If you look to the right side, the second last one. Security expert, really only 40%. You are on the internet and you think you don't need a security expert. That was very interesting for us. But what was not surprising was, for example, the professional software developer. So if you And there's over 70% say really, oh, we had this, or we wished we had this. A professional software developer is really helpful, or the quality assurance and testing expert. So from all these questions, and we looked also at technologies. So if you look nowadays at technologies, what is really used in the Science Gateway or virtual research environment world is you have widely used complete frameworks. For example, who has heard about Galaxy? Like it's a workflow-enabled Science Gateway where you can put things together. Galaxy is one of the examples. We could maybe go more into detail also. HUBzero is a nice Science Gateway. The Open Science Framework is, you heard about the Open Science Framework?
Yeah, we promote that. One of my colleagues, she's a representative for it, so we offer workshops through the library.
Yeah, very good. The Open Science Framework is also really, it's nice that you can put the publications in there and the projects, and so that is one. The Open Science Framework, so all the existing solutions have their strengths and focus, and so Open Science Framework, for example, is not the framework you use if you would like to start something in HPC. But it's a fantastic platform to share projects, to have your publication there, to add maybe data to your publication, to have the whole publication, let's say background. Yes, and it can give DOIs and all these things, so that is very good. So another trend in Science Gateways is RESTful APIs. That is like a standardized APIs how programs can talk to each other, and to support multiple programming languages. And this happens, for example, in Apache Avata or the Agave platform. And the Agave platform was, for example, the one what Cybers is built on, the one that has over 30,000 users. Or people reuse interface implementations such as the one of Cypress, the gateway. I've shown you the screenshots with the more than 25,000 users to date. And there's also Science Gateways out there where you can have the whole, the platform as a service where the resources are hosted, for example, Scigate is hosted at Indiana University, and you can have an account there and use their resources and their platform. So the lessons learned from the last years is that approaches should be really technology agnostic, using APIs or standard web technologies to be successful, or deliver a complete solution like Galaxy or HUBzero, and that community engagement is key. They have really the successful ones are really reaching out to communities. Of course, there's still always room for improvement, because otherwise everyone would have heard about Science Gateways and these solutions already. But they're really good in this. And if you look here, HUBzero instances worldwide, the picture you see on the bottom, so all where the little lights are, there's already a HUBzero instance. And the HUBzero, for example, resulted out of NanoHub. NanoHub is for nanotechnology, the Science Gateway, and they have over 500 simulation tools, more than 1.4 million users, and over 5,500 resources, which is very impressive. NanoHub is over 15 years old now, so they're a long time around. And HUBzero developed out of it as a generic Science Gateway, where you can adapt it to your own research domain, your own area. And here's again the usage of NanoHub, a little bit nicer than only the little picture. But you can see how, that is like 3 years ago, where NanoHub was all used. So HUBzero today, it's an open source platform. You can download it yourself if you would like to develop with it. It has a foundation where you can also be part of it and get for a small amount of money developer hours from the HUBzero team in Purdue. so they can help with the development. They do hosting services. They have over 60 hubs worldwide and more than 1 million visitors worldwide. And it offers already content management, so you can integrate your tools automatically. A collaboration platform, you can add publication and project management. So there's kind of, it's a really nice complete solution which you can adapt for your own research domain. So these are a couple of examples that it's really also totally different research domains. So for example, the NCIP hub is in cancer research. So PUR, I think they say PUR, PUR, is a data management solution. That might be something interesting to look at, because it's already done for Purdue University researchers and collaborators. So for HPC resources, the DiaGrid is research tools that you can access directly, data resources, but also high performance computing and high throughput computing. So they have already a couple of different solutions out there. So with the technologies, so the point is that reinventing is not always necessary, only because we think it might be cooler to do something different. And users should get more features easily. It should be easy to adapt. So that is one of the measures for successful frameworks in Science Gateway. But it still should fit, of course, the demands of the community. So there's, reusability is one of the big topics around Science Gateway, because you can share knowledge and data, and you can reuse recipes and workflows when it's set up in a Science Gateway. But it's really also about reusability of software. Because most of the Science Gateways are open source. You can download, you can play around yourself with them. And so I like really what John Bourne already said in '92. The key to productivity is reusability. The easiest way to produce code is obviously to have it already. Nothing is faster than that. Just, if it fits, of course, what you want to achieve. And another big topic for Science Gateway is really usability. And Steve Gluck has a couple of books on Don't Make Me Think and Rocket Search is really made easy. It's really good books about web applications, usability of web applications, common sense. So, and I like always this, what I found on Facebook about usability. A user interface is like a joke. If you have to explain it, it's not that good. That's the way it is, huh? I mean, if you have to explain it, that doesn't help so much. And people, if they have the choice and something is not so usable, then go to another solution. That's the way it is. And we have to talk also about software sustainability in academia, because we have always these funding cycles. We have 3-year projects or 4-year projects. And then you create software, and how to really evolve and maintain it over time in all these funding cycles. How that it really still fulfills its intent over time and survives the uncertainty of funding and also supports relevant concerns. So that is WSB, that is a working group which looks at sustainable software for science. So the Science Gateway Community Institute is founded for 2 years now. It has another 3 years for sure, and hopefully after that another 5 years. But then we have to be sustainable ourselves, and we have these 5 areas. So the Incubator area is really diverse expertise on demand. So if you have the need to, for example, for a usability specialist, or for a security specialist, or quality assurance, you can contact us and we help you in your project, in your Science Gateway with this. Or the extended developer support. You can have up to 1 year a developer who helps you to build your science gateway, your research software. We have the Scientific Software Collaborative that starts with a catalog now. There are a lot of science gateways frameworks, but also particular solutions are listed that you can find what is already out there, maybe something that fits for you. The community engagement and exchange, you can, have information exchange in the community environment. We have like a yearly conference, we have webinars, giving talks at different universities. And we look at workforce development, really that students get opportunities and foster a career path in the area of science gateway and software development. So I talked already a little bit about the 5 areas. I make this a little bit shorter. So it's really, the incubator service is helping to make projects sustainable, gateways sustainable. And for example, helping with choosing technology, or with cybersecurity, or with software engineering, or do something like usability studies, and look at evaluation and impact measurement, or at campus resource development. That really on-campus resources, that there are teams who can help with science gateway development. What we offer is twice a year a bootcamp. That is a 5 full-day bootcamp, and it really is on the one hand side for science gateways, but more for research projects in general to look at sustainability. So one thing is really, you look at, you have an idea, you want the science gateway, you want this project. So how do you articulate the value of what you're doing? How do you can really say, oh, this is distinctively different from everything else that exists at the moment? Because you have to sell it to your stakeholders and who benefits from this. So where does my solution fit in with competitors or in the research area you are in? And how do I make it really happen? So that you have really measurable goals for success and sustainability. And how do I sell it? How do I go out to the community and show them that it's, and what are my customers or my clients in this regard, really seeing it a little bit like a business project. So that's just, twice a year you can apply for this, and we got a lot of, so we asked every time, we had 4 of them now, whether people had magic moments, for example. And people, yes, they had magic moments. So we talked about our campus teams there, and one was saying, I'm planning to organize a gateway community on our campus, including humanities, libraries, engineering, and science, and create a strategic budget request to our campus leadership. Because that could help to make your projects sustainable. So if we remember, I started from the research software point of, the use was 95% in the US and 63% that they cannot continue their research without, but 50% have neither formal nor informal training in software engineering. So where comes all this research software? How can we sustain it? How can we help with this? And there's a lack of career paths for software developers in academia. So to help with this, let's have a look at time and cost for on-campus teams. So a typical research team for developing science gateways to bring research to your community looks, PhD student and maybe 1-2 postdocs, maybe 3. An extended research team could be already, if the teams are bigger, have maybe 1 professional software developer. But shared on-campus team could be really, if you share it with several teams, it could be something that you have a Q&A expert, a security expert, a usability expert, a graphic designer, but you pay only slides of these experts, and other teams pay the other slides, so that you can have all this expertise for your project. And so there's an increased possibility of the research team to focus on the research. And there's increase of the quality of the application and efficiency of the software development, because we have for the single pieces the experts. So that could be a solution because it's really a challenge to build a team per project. Because you need only, for a science gateway, for example, a usability expert. If you have a 3-year project, you don't need a usability expert for 3 years. You need a usability expert at the beginning or maybe in between. Or you need this diverse expertise so that several different people are needed, because otherwise we all feel like this and that we have to do all the different all the different tasks, and not even this art with 8 hands manages that. So there's an opportunity to work together, because there are a breadth of interesting topics in the science gateway creation process. For software developers, it could be the novel frameworks and web applications, but it's also an inter and multidisciplinary work. So to work together on really ground challenges like malaria eradication, that's very interesting. And you have the breadth of interesting roles to work with designers, to librarians, statisticians, machine learning experts. So to form this team beyond one project. So there are, diverse groups aiming at improving the career paths for on-campus teams. So SGCI is the Science Gateway Institute I'm talking about, but also ERSI, the conceptualization of a US Research Software Sustainability Institute. So I'm one of the co-PI of this institute also, and there's a US Research Software Engineer Association, which is starting to form at the moment, ACI-REF, the Campus Research Computing Consortium, NSF is looking at these things. So I don't want to go much more into detail for career path. Who of you would be interested in hearing more about career paths for software developers in academia? If you want to hear more, you have to do this. Okay. Then we skip this part, because you have heard it also already. So another area of the Science Gateway Institute is the extended developer support. This is really what I said, like, up to 1 year you can get a developer to help you with your Science Gateway. The Scientific Software Collaborative is really, it's a catalog. It's helping to find solutions, but also it's like having the chance to try the Science Gateway and see what it's doing, without that you have to have it already yourself installed. So the Science Gateway catalog, for example, you can find on the website, on the sciencegateways.org, and then the catalog. And if you, for example, so I searched here for humanities. So all in all, there are now 446 entries at the moment. Then you can see there's, for example, an open curation of computation and metadata project, or the Center for Academic Research and Training in Anthropogeny. I hope I said that right, pronounced that right. So you can find for all the different areas you might be part of, you find already examples there. And then it's easier, because one of the problems is how to find existing solutions via Google. It's so hard, because a lot of people don't use the expression Science Gateway. What are you looking for? Platform, framework, what should you put in? So it's really, we try to put everything in a catalog that you can find a good amount of existing solutions. And it's easy to create an account, and I promise you won't be spammed. It's really one-step account created, and then you can also add your own solution there. If you would like to have your own science, if you have already your own Science Gateway or a solution you want to advertise there, you can put it in there and add it to the catalog. The community engagement and exchange area of the Science Gateway Institute is really about, we have the annual conference, we have the Campus Gateway groups, task force building activities, we have website activities, webinars. So if you are interested, for example, to talk about your research, you can contact us on one of our monthly webinars. Yeah, here's again the conferences and workshops. And the conference in the US partners with the European International Workshop on Science Gateway and the Australian one. So there are 3 events mostly each year since 2015 now on the different continents, and then they partner on a yearly special issue in a journal. So we have the workforce development to support really the students to work with science gateways. And there's a lot of opportunities to work with us to get advice on sustainability, usability, cybersecurity. Or you can work with us to build a gateway for you. Or we help to find a working gateway or gateway development software in the catalog that fits your needs. Learn how to set up a gateway group on your campus. Keep up to date on gateway developments. You can enroll a student in an internship program to learn gateway developments if you have students. Or you partner just with us on your own projects, technologies, and events. So that is how you could work with Science Gateway Institute. Yeah, and this sounds almost a little bit creepy. You are not alone. No, we can help you. It's the right time to do this. And are there any questions up to here? So the services are clear. That's, if you're interested to get. So what we could do now is to make a real get a hands-on session and a little bit of a demo with Galaxy to get a little bit more impression what you can do with a specific science gateway. I think it got clear that they all look a little bit different, that they're also different for each domain. And I only have to go here. And maybe we make a break of 10 minutes that everyone can grab the lunch already? Oh, yeah, maybe that's a good time for the lunch. There's a lot of Science Gateway frameworks start to offer Jupyter also as part of the user interface. You can have these really very pre-configured, like the examples I've shown, or people can really put in, their own scripts into Jupyter notebooks. So I've seen that both is taking up.
Yeah.
So, are you in physics?
Yeah.
Yeah, good, yeah.
And chemistry, actually. I work in the chemistry department.
Yeah.
Research involved.
No, it was only the lucky guess from someone from physics was on the participant list.
Yeah, she's in my lab, actually. She could make it, but.
So I only thought, okay, if you are using the Jupyter notebook, it's probably because you like to script your own thing. Yeah.
Yeah, exactly.
Yeah.
We use OSC primarily, but.
Ohio Supercomputer Center. You were
No,
talking
that makes
about.
totally sense, yeah. So this is a little bit really the direction it goes in this area. It's totally pre-configured science gateways, or really that people can put in their own scripts. So because both is there and both should work. So one of the very pre-configured science gateways I show you now, I'll make a short demo, is a Galaxy, which sounds almost like physics, but is in the biomedical community mostly used. And what you can see here is, so this is how you see it. Here are tools, like a toolbox.
Slowly, yeah.
You can use them here, like, for example, upload file from your computer. And I can choose a local file. I don't have a file here prepared now, but you actually know how these things directly work. So you can upload files or get them from different servers. And you can see this one, it shows really the example for the biomedical community. And the other thing which is really nice, you can create your own workflows. So, okay, this one, they changed that. Let me see whether I have whether I still have my account. Of course. Let me. No, when I tried it the last time, and this is only like a week ago or something, I still could use it. So, okay, forgot password. And you can see that there was on this computer already a couple of people who did that. That's interesting. So you have some more Galaxy demos here. Only last another half minute. So, no, I don't want to save my password here. So what we can do now, only to explain a little bit how Galaxy works. So the whole screen is a little bit split. What you see here is what I said, like a toolbox. So you have different tools which are pre-configured by an administrator of a Galaxy. So that is done by the administrator. In the middle, you can see information, or we will go to workflows. And what you can see here is all my old data. For example, what I worked on, the jobs I worked on. When it's green, it was a successful job. But we can also test something that it's not successful. But you can see that I had 38 different jobs on output of data here. And you can always have a look at the data. This is, for example, a sequence. In tabular format, this is in faster format, this is a specific sequence format for bioinformatics. This is also a faster format. You see here the next gen, or the sequence for the genomics, for the gene. So this is really from different jobs I have done before. So what I want now is, for example, to create a workflow. So I could, for example, import a workflow. And it throws an error for the moment, but this is my workflow I have created already in the past. What you see are the connectors between the different jobs. So here, for example, you see that these both files are going into this join job. Then I group them. Then it goes to a sort. and then I select something first, and then I compare two data sets. And when I start this shop, I probably get now an error, but we can try this. So what we do now, show it to panels. Now it should show up in my tool panel here. And now I can run the workflow. Now the data set is not available, so let's see whether I can find it in my old data. Okay, this is an old workflow, and therefore I already said that this probably won't run because I don't have the data sets anymore. It's almost a year old. But you can see how it works here. You can click together your own workflow, or you can import workflows, a conversion workflow, for example, and then you can run them. And you get the results on the right-hand side in this part of the screen. And you can use all the tools you have accessible here, all the workflows you have created. So for example, I could now, the output file is a FASTQ format here. Let's see, if I would like to extend this workflow with another step, what I can do is add another step here. And make, for example, just click on it and connect these files. And at the moment it doesn't, because it has a FASTQ and it's at input name as a column, it probably needs another data set. Let's see whether this connects here. So I have a tabular output here, and I can add as an input as column here, and I get then another output here. So this is very simple workflow. I would think that I can start this one without a problem now. So let's see, run. Okay, I have to save first. Save. And then I say run. Looks all good. So now it runs this conversion workflow, and you see here now it stays here. In gray means that it's running at the moment. Oh, that it's waiting, sorry. The gray means, and the yellow means, and the green is that it did run now. That you can get the details about it. What was the name, on which kind of data I did run it, what is the Galaxy tool ID out of the left-hand side, and you can also see all of your parameters, the tool parameters which were given in. Similar here for this step. So Galaxy is now really always enumerating all the different steps, and you can see the results. You can download the results, you can see the details. Partly you can visualize this data with Jupyter. This one doesn't have really a script behind it at the moment. So there's still some room for improvement also with Galaxy, but you can see the logic directly. You can start just the tool, or you can put tools together as a workflow, save the workflow, and always restart it for different data. So if someone shares then a workflow with you, you can reuse it, especially this word was an ED workflow, but some of the bioinformatics workflows have 20 or 25 steps. So you can just start it in one go and see always a different output there. So this is one of really wide used science gateway, which is also workflow enabled. As far as I know, Galaxy will come also to campus here, so that you can try it. So this is really, with visualization, it has a lot of room for improvement with regard to visualization. You can share data between users. You can share also your histories with other users. That could be interesting in a collaboration if you're working on a publication, if you're working on a project together. So you can have data libraries. Like this is really like the 1,000 genomes, that is one of the typical data libraries for this field. But you could be, in physics that you want to share specific different data, have it in the library, load it up there, and if you put it in the library, also all your collaborators can see it. So you can decide whether you want to make it publicly available or available to a group. Then you can use it. So if you look, for example, here, you see that there's different genotypes, different data files in one folder, and you can just share these. And it gives more explanation. It helps also if you have certain file formats, that only these file formats are also allowed then for certain tools. How I couldn't connect the two jobs with each other, well, Galaxy was like, no, you cannot connect these two because the output one job was not fitting to the input of the next one. So it helps with these things. So yeah, that would be a, let's say basic demonstration of Galaxy. Do you have any questions about this? So I mean, we could do more complex workflows here, but I think the concept is clear about how this works. Are there any further questions about science gateways in general, or other technologies or frameworks you would be interested in, or should we maybe go a little bit more through the catalog of science gateways? Maybe we should just eat. That's also okay with me. Okay. So I mean, if you have any questions regarding more technologies or what kind of interesting solutions are out there, as I said, this is a very specific example. Could show you also a little bit more about HUBzero or another framework, but it's all, if you know what you directly want to see, or the Open Science Framework, you know the Open Science Framework. Okay, so I could show the Open Science Framework a little bit how you put projects together and upload your publications and link them with GOIs and also presentations, that you have everything for one project together. So these are examples for science gateways. And so maybe we eat for the moment our lunch.